Yeah, watch this. You want to see something freaky? 2R. Whoa. What does that mean? What does that mean? For the ideal can,
Well, it has to be the same total width, like the same diameter as the height.
the diameter, which is 2R, is the same as the height. In fact, it looks like a little square. If I held it up like this, or if I held it up like this, and you were looking at it, it would look the same. The distance across the top, the diameter, is equal to the height. That's the perfect size cylinder that you want. Is this the perfect size? Does this use the least amount of material? No. It's a little bit taller. So why would they do that? What did you say? You can actually grab it, okay? It's very comfortable. They probably do statistics on the size of people's hands. And it's all based upon ergonomics, which is a huge concept in engineering, okay? So I can grab this can very easily. If I made this can a little bit shorter and a little bit wider, it'd be a little bit more difficult to grab, okay? Now, this can, the 8-ounce can, is more like the more ideal, okay? They use less material for, they use more of the correct amount for this guy. All right, we gotta quickly do this to minimum. I wanna graph this equation and I wanna see if we've got our correct answer. So, go to y equals, and I actually have it in here already. I did it 2 pi x squared plus 710 divided by x. Okay, this is our area, this is our surface area formula. Now, if you take that in and you do a zoom 6, this is what you get. Not very helpful. Okay, so my little secret on this is I hit the trace key and I'm at x equals 0, so I'm going to just go to the right here and I'm going to take a peek over here. These are the surface areas. Look at that. It's up over 1,000. Okay, so if I keep going to the right here, this keeps going down. Looks like it bottoms out around 270 something. See that? And then it starts going back up. That's where our minimum should be. Okay, so here's what we're going to do. I'm going to change the window. Change the window with me. X is of 0 is a minimum. And let's go to like, yeah, 10 is fine for a maximum. And then we'll go by ones. 0 is a minimum. Now that represents our surface area. And we'll go to like 1,000. And we'll put a notch every 100. Okay. These are the dimensions for the graph. And let's see what happens. Graph this. Now we're talking. Okay, so if I hit the trace key, here I happen to land at x equals 5, and I came out with 299. What does that mean?
When the radius is 5, the surface area is
299. Everybody get that? The radius is 5, the surface area is 299. Is that the most efficient way, the most efficient radius? No. Right at the bottom would be, so let's calculate that bottom. So we can use that on our calculators. Second calc, we're going to go to minimum. We go to the left of it. Press enter. Go to the right of it. Press enter. And then just find someplace in the middle and let it do its thing. And voila, 3.8372. We found it. Notice, this value is the cubed root of 710 over 4 pi. Okay? All right, now, we got a couple things, important things to say yet. Okay, guess what? Pepsi's, you're being hired as for Pepsi, and now instead of 355 milliliters, they've decided that for the holidays, they're gonna create a whole edition, which is like different sizes. So they get the 355 milliliter, the 500 milliliter, the 750 milliliter, the 1000 milliliter, the 1400 milliliter, and they want them all to be the perfect design. Now go do it, but you only have 2 minutes. How could you modify what we have so you don't have to do the same problem over 6 times?
You just change the top, like the 710, it's 2 times whatever volume.
Exactly. Let's go right here. Does everybody see that? I'll start here. The height, I'll just call it V for the volume. See that? That's your height. Over here, this is 2B. And you're done. Now all you need to do is plug in the volume, and you've got it generically for every situation. Now, actually, that's not the most efficient way to make a can.
I was drinking out of those things. There's like more.
When I saw this Saturday,
Oh, I saw this too. I wanted to buy them off and let me do that.
I just about jumped up into the air screaming because I've been looking for this forever. This is the most efficient way to have a container to hold the most amount of soda with the least amount of material. This is it. Isn't it cute?
It is so cute.
This actually is not 12 ounces.
It's more so. It's 13.
It's 13 and a half ounces. So when you even when you look at this, this uses more. It holds more than this guy, and I bet you it still uses less material. Isn't that cool?
Are they only gonna do it for a season?
They only do it for a season. Jerks.
It's quite hard to relate.
Those, you have to remix soda machine and everything just to go with